in a science fiction book. Today, robotics is used in many areas and is important to the future of mankind. There is one technological advancement that would certainly make living easy and convenient. Robots will be the answer. Robots are human-like machines capable of doing tasks they are programmed to do. They have shown significance in decreasing human workload, especially in industry. Robots are mostly utilized in manufacturing industry. The type of job that laborers encounter in this kind of business is usually monotonous. People who do the same thing for a long period of time tend to get tired and bored. The person who reaches this point will not be as effective and efficient as he first started working. Also, as human beings, we get exhausted, so the length of time we can work is only limited. This is when the importance of robots is realized. They can be set to a function for a long span of time, producing the same quality product all throughout the production process. This resulted to an increase in the number of manufactured products and decrease in the production of defective goods.
Or the day will come when robots will really assist mankind.
The nuclear disaster in Japan sparked explosive advances in humanoids at the front line of robotics development. This program explores the future that's fast approaching.
Robotics is a branch of technology that deals with the design, construction, operation, and application of robots, as well as computer systems for their control, sensory feedback, and information processing. The design of a given robotic system will often incorporate principles of mechanical engineering, electronic engineering, and computer science, particularly artificial intelligence. The study of biological systems often plays a key role in the systems engineering of science, and also forms the field of biology. The mathematical expression of a biological system may give rise to control algorithms, for example, or by observing how a process is handled by nature. For example, the bipo-matrix system, an analogous system in process of electronics. The concept of creating machines that can operate autonomously dates back to the classical times, but research into the functionality and potential uses of robots did not grow substantially until the 20th century. Throughout history, robotics has been often seen to mimic human behavior and often manage tasks in a similar fashion. Today, robotics is a rapidly growing field as technological advances continue. Research, design, and building new robots serve various practical purposes, whether domestically, commercially, or militarily. Many robots do jobs that are hazardous to people, such as defusing bombs, mines, and exploring shipwrecks. The word robotics is derived from the word robot, which was introduced to the public by Czech writer Karel Čapek in his play Rossum's Universal Robot, which was published in 1920. On the other hand, the word robot itself came from the Slavic word robota, which means table. What then makes robotics? Well, robotics is two different but inseparable processes. The design of the physical manifestation of the robot and the development of the brain, the program that tells the robot what to do. With the building process comes the need for creativity because there are several ways to build a robot that can do one task. And the challenge is to find the most efficient design. This process also requires careful planning and execution because it is easy to mess up the right things in a machine, causing it to short circuit or malfunction. Unstable designs also make the robot less durable and very impractical. Let's go find the robot. This is their natural habitat. I can sense the robot something close. Look! There's a robot! Very magnificent design. Here, please, Earl. Actual live robot! You must be careful not to reach the face. Amazing, guys! It's dancing! Well, anyways, back to my report. Then
there's the programming part, where the instructions for the robot are made. This part requires logical thinking and gets increasingly harder as the number of tasks the robot has to do increases. Of course, building and programming are relatively easier done separately, but that is where the difficulty in robotics lies, in the separability of the two. Without first conceptualizing a pseudocode for the function, it is hard to visualize a design for the robot, and the other way around as well. The design has to support the program, and the program has to be smart enough for the design. A robot with multiple functions and a complex program will usually come with a complex design as well. This is one of the main reasons why robotics projects and competitions are usually made of teams with a separate programmer and a builder. Wait, I think it has another function. It's an MP3 player.
Dr. David Barrett, one of the most well-known roboticists in the world, sum up three biggest challenges in robotics. The three biggest challenges in robotics are creating better batteries, creating better actuators, and addressing the need for an industrial-grade hardened and rich supported software development system. To create better batteries, according to National Instruments, a producer of automated test equipment and virtual instrumentation software, they will add built-in self-diagnostic and monitoring API to compact Rio and NI single board Rio platforms to gain greater insight into the power status and to design more graceful shutdown and power save modes. They will also provide more efficient control algorithms like field-oriented control or FOC for field programmable gate array or FPGA based control, which improves sinusoidal control by providing high efficiency and faster motor speeds. To have better actuators, roboticists should have first-hand experience with actuator connectivity as well as current focus to improve the interaction with and control of actuators and work with professionals in the industry to make programming this device much more straightforward. Lastly, the biggest challenge for roboticists is to have a powerful software to design their autonomous system, software that is not unique to a particular robot or task. To solve this challenge, the software must be intuitive. The software must integrate well with input or output. The software must be open and flexible, and the software must be interactive. There are a lot of innovations coming from the world of robotics. One of them is the bionic leg. Though bionic legs are of course a huge tool for marketing, they lack actual nerve connection to the body. As a result, walking on them is cumbersome and challenging. Lastly, Seattle resident Zach Potter was outfitted with the world's first thought-controlled leg, a bionic limb that takes signal directly from his spine. This technology previously existed for arms, but legs are rather more complicated. And since a misread signal can send you jumping off a bridge or in front of a moving car, thought-controlled leg needs to be more stringent programming than equivalent arms. As one of the researchers delicately put it, if you are using bionic arms and it misbehaves, the elbow may move slightly. But if the prosthetic leg misbehaves, that could be quite a sentence. Warren climbed 103 floors of a Chicago skyscraper on his bionic leg, but its designers are still working on improving it. To optimize it for everyday use, they have to make it even clearer and lighter. If successful, the high-leg Air may meet the Army's stated goal for bionic leg, 10,000 steps without recharging.
The humanoid development won us 2000 a decade. I think we can say that the most famous humanoid development robot is Asimo, produced by Honda. Asimo is actually an acronym that stands for Advanced Step in Robotic Mobility. Asimo is the culmination of 2 decades humanoid robotics research by Honda engineers. Asimo can run, walk, up the stairs or down slopes. Asimo has the most fluid movement when it comes to human life movement. It can also register 10 faces of 10 selected individuals. Asimo can map its environment and register stationary objects. Asimo can also avoid moving obstacles as it moves through its environment. bomb disposal and diffusion. Diffusing and disposing bombs can be very delicate and dangerous. This may lead to complications that the person doing may accidentally cut the wrong wire, and that will cause a life to lose. Now, robots are the ones who became in charge in bomb disposal and diffusion. Bomb disposal or explosive ordnance disposal or EOD robots are ones to use armed weapons like bombs. It is equipped with an arm-like manipulator, sensors, and a camera on a boom for enabling operators to remotely disarm and provide explosive devices. The technician working in the robot will sit at a safe distance from the control station. This is a laptop-like device which consists of a monitor showing the robot's point of view, as well as the surroundings, plus a joystick and a control panel to manipulate the arm and maneuver the tracks. Spiders are stuff from which nightmares are born. The Team Octopod robot is a nightmare when reprised. Take a look at this video clip. Roboticists have been trying for years to mimic the architecture of a spider. With 8 legs, you get unprecedented level of stability, which is great for search and rescue operations in disaster areas. And while we've had other versions of spider-like robots, it's always been difficult to design one with enough internal control for all 8 legs to move in unison, while still retaining the ability to move separately when needed. The T8 robot uses a unique movement engine designed specifically to overcome that obstacle. It's remote controlled, and with a simple command, the onboard processor will calculate leg trajectory, motor control, and inverse kinematics to coordinate its 26 individual motors. The result is almost too lifelike.
Oh, hey there. Since our topic is about robotics, I made a sample robot for a little preview about robots. Since I have a little experience in robotics in high school, you can see it here. Robots have main parts. In this project, I've used parts like servo motor, the sensors, the circuit board or the Arduino, which is the main brain, so-called main brain, the batteries, the wires, the breadboards, the engines, and the wheels. I include a video on how I assembled this robot. robot is that it will avoid any obstacles. Or to put it simply, when this sensor turns, it will find a way where there will no hazards or obstacles.
Guys. Okay, guys. Back to my quest of finding robots. Look! Robots everywhere!